Okay, this video will be on the first unit of the Trig chapter. I want to start with some basic concepts of Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared, keeping in mind that your hypotenuse is opposite the 90-degree angle. That's something that's always easy to find, okay? So in this example, if I had to solve for x, okay, this obviously is the hypotenuse, okay? These are the legs, all right, leg and leg, all right? So I got x squared plus 3 squared equals 5 squared, all right? That would be 9 and 25. And if I subtract 9, I get x squared equals 16, and then take the square root of 16, I get 4, okay? If you get a nice, easy number there, all right, that's great, okay? All right, now, sometimes you won't get that. For example, in here I got 4 squared plus 8 squared equals x squared, okay? So that would be 16 plus 64, all right, which would be 80, okay? The square root of 80 ends up not being a good number. So what we're going to have to do is break down the square root of 80, okay? So I'm going to go over briefly how you do that with a radical, okay? All right? You divide by, see if you can divide by 2 or 3 or 5, all right? So sometimes you divide by 2, 3, 5, 7, your prime numbers, okay? So 2 and 40, then that goes to 2 and 20, then that goes to 2 and 10, and that goes to 2 and 5. How do I know that I stop? When both numbers are prime. I cross off everything with a double branch, okay? If it's a square root, I'm looking for pairs. So here's a pair, here's a pair, okay? My leftover here is 5. That goes on the inside. I take 1 out of each of these, so 2 times 2, so that would be 4 square root of 5, okay? We should all know how to do that from Algebra 1 and Algebra 2, okay? So that's what that part equals, okay? All right? So why don't you take, pause your video, take a few minutes, and just do these Pythagorean theorem questions, okay? All right, so this one would be 5 squared plus 12 squared equals x squared. That's 25 and 144. That's 169, and the square root of 169 is 13. Okay, pretty simple, all right? Pretty simple. This one, this is the hypotenuse here, okay? So it's x squared plus 3 squared equals 9 squared. That's 81 and 9. Subtract 9. That's 72. And take the square root of 72. It's 2 and 36. 2 and 18, 2 and 9, 3 and 3. Okay? Got multiple pairs here. Pair here, that's left over of 2. I got 2 and 3 there, which will give me 6. So 6 square root of 2. If you have multiple leftovers, those obviously go on the inside. So you should always see if you can do Pythagorean theorem for the sides. Okay? If you got 2 sides, you can always use Pythagorean theorem to get your third. Okay? Nothing new there. Now, let's take a look at this example. All right? So what happens here with this is, let's say they're asking you to find x. I can't use Pythagorean theorem for this right triangle because I'm missing 2 sides. So what I can use is some basic trig, which is SOHCAHTOA, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? Now, how do you figure out which trig function to use? The first thing you want to do is you want to label the hypotenuse, the opposite, and the adjacent. The hypotenuse we've already talked about. That's the easy. That's opposite the 90-degree angle. The opposite goes off the angle. So what you have to do is, if my angle is here, then that would be the opposite, which would be x. Okay? This would be the opposite side. This would be the adjacent. Okay? So once you label, what you do is you pick your trig function, all right, off of what 2 sides do you have info, meaning a variable or some number, okay? So if I look at this, I got stuff for hypotenuse, I got stuff for opposite. So that would be sine. So sine, then I want to do is I want to fill in sine of my angle equals opposite over hypotenuse, okay? So fill in that stuff, and then the last step is you solve, okay? You can use your calculator for this, okay? All right, now, what you're going to do, if you're at this screen, you hit Shift and Menu, make sure your calculator is set into degree mode, okay? So I got 45 sine of 29, okay? All right, type that in, get my answer, 21.816. That's how easy that is, okay? So when you have that there, what happens is that 45 moves up. So I got 45 sine of 29. That's how you type that into the calculator, okay? Let's do two more examples. Let me show you the two other solving ones. Let's say I got this, okay? Say I got this. Well, this clearly is, let's say I was trying to find, what do I want to find here? Let's say I want to find that, okay? So this would be the hypotenuse, okay? If I do a little dashed line here, this ends up being the opposite, okay? So be very careful of listing your opposite as always the one that's vertical. That depends on the question, okay? Now, this then becomes the adjacent, all right? So what two letters do I have information for? Opposite and adjacent. So that's going to be tangent. So tangent of 50 degrees is equal to opposite over adjacent, okay? Now, how do I solve? If you notice, the variable's in a different place here. So what I want to do to solve is I want to take that and move it underneath. So it's 80 divided by the tan of 50, okay? 80 divided by tan of 50. Okay, so I got 67.127. That would be my answer for that. All right, let's go on to this next one. Okay, so what I got here, this would be the hypotenuse. All right, if you see, I'm trying to find the angle here. This would be the opposite, and this would be the adjacent. Okay, so what two letters do I have information for? Adjacent and hypotenuse, which would be cosine. I don't have my angle here, adjacent over hypotenuse, okay? Now, when you're trying to find the angle, okay, so if I had, in this case, cosine, I'm going to do what they call inverse cosine of my ratio. So I use this little -1. I'll show you where that is on the calculator. If you have sine, you would use sine inverse. And if you had tan, obviously you would use tan inverse. I want to be really clear on that, okay? So if you look at your calculator, there's these little -1 buttons right above it. Okay, so that helps you find the angle. So I had shift in that, okay, 19 over 47. Okay, I get 66.155 degrees, okay? All right, so what I would like you guys to do, okay, is go ahead, forgive my drawings already because I already did this video once already and the iPad deleted it. So go ahead and pause yours and go ahead and work on this, okay? Go ahead and unpause, all right? So what I got here, this would be the hypotenuse. If this is my angle, this would end up being the opposite, this is the adjacent, okay? I got opposite and hypotenuse, which would be sine, so sine of 32 degrees. The opposite is 95 and the hypotenuse is x. So how do I solve that? That's going to be 95 over the sine of 32. That's 179.272. Okay. This one, this is my hypotenuse, this would be my opposite, this would be my adjacent. So in this case, I got opposite and adjacent, which would be tan. Tan, my angle is x, opposite is 52, adjacent 79. How do I solve that? I do inverse tangent, 52 over 79. So I get 33.35, 354 degrees, okay? All right, and then the last one here, okay, this is clearly the hypotenuse. All right, if I drew a little dashed line, this would be the opposite and this would be the adjacent, okay? So I've got hypotenuse and adjacent, so that would be cosine. Cosine of 56 degrees is equal to x over 70, all right? How do I solve it when it's there? I move that 70 out in front. 70 cosine of 56. All right, 70 cosine 56 gives me 39.143. Okay? So that's some basic trig. All right? Now, what I would like to do, all right, let's move on to something else. Okay? Let's say, all right, and I'll talk about that theta in a second. Okay? Let's say I had, and the direction said, find all 6 trig functions. Okay? Find all 6 trig functions. Okay? So, what we want to do on this, okay, pretty simply is this. First of all, somebody say, Mr. Evans, we only talked about 3 trig functions. Okay. So, we talked about sine, cosine, and tangent. And we talked about them in this context. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. There are 3 other trig functions, okay? All right? Something that says CSC, which stands for cosecant, okay? That will be the opposite of sine. So instead of O over H, it's H over O. There is one that says SEC, which stands for secant. That is going to be hypotenuse over adjacent. And the last one is cotangent, okay? Cotangent. And that is going to be adjacent over opposite. So as you can see, they are reciprocal functions of each other. Now, the way you can remember it is the letters don't match up. SC, CS, okay? You don't have S and S, C and C, okay? So no letters match up, all right? Now, what we want to do, we have questions like this, and we'll do more things like this later in the chapter. First thing is you want to do is you want to find the missing side. Okay? Using Pythagorean theorem. Okay? So this side right here is a leg. So I would do leg squared plus, let me move this out of the way. All right, I would do leg squared plus 15 squared equals 17 squared. Okay, that little angle right there stands for theta, okay? That's theta. That's like a generic angle. They're not giving us a measurement. They're giving us a generic thing. So 15 squared, 17 squared, okay, 289, 224. Okay, subtract 225. That, I think, gives you 64. And then you take the square root of that. So the leg is 8. Okay, so that part's 8. Okay, all right. What we want to do is we want to label, just like we've done before. So this is my hypotenuse. So this is my angle that I'm going off of. So this is the opposite, and then this is the adjacent. Okay, all right. And then you just got to find the ratios. All right. So what I'm doing is sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Okay? Now, this is pretty simple. If sine is opposite over hypotenuse, 15 over 17, then cosecant is just 17 over 15. Flip that starting ratio. Cosine is 8 over 17. Okay? Flip that ratio to be 17 over 8. Tangent is 15 over 8. Okay? Flip that to be 8 over 15. Okay? All right? So that's some basic stuff there with the trig function. Okay? I don't think that's overly complicated. Now, when we get later in this unit, we're going to introduce negatives and radicals and all that, but for today, I don't want to get into that. Okay? So let's say I had this example here. Let's say I had this, and let's say I had 25 and 7, and I said, find all 6 trig functions. Okay, so what I'd like you to do is pause your video and go ahead and work on that. Okay, go ahead and unpause. Okay, all right. So if I did the Pythagorean theorem, that's legs squared plus 7 squared equals 25 squared. That's going to be 625 and 49. Okay, subtract the 49. So I got legs squared equals 625 minus 49 is 576. And the square root of 576, I think ends up being something nice. It does. It's going to be 24. Okay, so that's 24. I label, this is the hypotenuse clearly. Since I'm going off this angle, this is opposite, and this is adjacent. Okay, so sine of theta is going to be 7 over 25, which means cosecant of theta equals 25 over 7. Okay, let's say I got cosine of theta. That'd be 24 over 25, which would make secant of theta 25 over 24. Then I got tangent of theta, 7 over 24. Cotangent of theta would be 24 over 7. Okay, keep it that simple for right now. We'll talk about sines a little bit later. Okay, what I want to move into and finish this lesson with is something called the special. Okay, the special right triangles. Okay, there are 3 special right triangles, and I would like you to draw them out. There's a 30-degree triangle. There is a 45-degree triangle. And there is a 60-degree triangle. Okay? Now, all right, we want to reference this to, we're going to tie into the unit circle coming up in this next lesson, okay? And the idea of the unit circle, and I'll draw that out next time, okay, is the idea that the hypotenuse is 1, okay? All right, that the hypotenuse is 1 unit, okay? All right, we'll talk about more of the unit circle next time, but just for right now, just write that down, all right? Now, what that means is if my hypotenuse is 1 for all of those, okay, the question would be, is based off of these triangles, okay, what would those results be, okay? Now, if we did our basic trig, okay, and we figured out what this side was and that side was, okay? Okay, what this would end up being, okay? All right, would end up being 1/2, okay? All right, because sine of 30 degrees is, if I had labeled this as x, would have been x over 1. And if I do 1 sine of 30, I end up getting 0.5, okay? All right. Now, if I end up doing cosine of this, all right, what ends up happening is that ends up being square root of 3 over 2, okay? All right. Cosine of 30, yes. Just want to double check this real quick, just so I'm explaining it correctly. 3 over 2, okay? And that's what that one would be. If I applied the same principles, okay, this one would end up being square root of 2 over 2, and so would this one, okay? If I apply those same principles, this would end up being square root of 3 over 2, and this would end up being 1/2, okay? Now, what we want to look at, okay, what we want to look at is we want to not deal with these crazy fractions. So the very simple thing to do, instead of dealing with halves, let's multiply all these by 2. So now this would be 2, this would be 1, and this would be the square root of 3. Okay? Same thing here. This would be 2, this would be square root of 2, and this would be square root of 2. Okay? This would be 2, this would be square root of 3, and this would be 1. Okay? So that's what we have to look at. Okay? There are those amounts, and this is something you're going to have to memorize and get good at. okay? Now, you should notice something interesting, is that triangles, okay, triangles have, the degrees in a triangle add up to 180. So this is 60, and this is 60. I'm sorry, this is 30. So these triangles are sort of opposite. As you can see, they sort of have the same values, okay? So what you have to know is 30 degrees is opposite of 1, 60 degrees is opposite of square root of 3. And that's the same thing. 60 is opposite of square root of 3, 30 is opposite of 1, okay? And this is the other part you have to memorize, okay? And what we're going to do next class is we're going to apply those, okay? But these are going to be the core things that we're going to have to look at. Is that the 30-degree triangle is 2 square root of, is 2, 1 square root of 3. The 45-degree triangle is 2 square root of 2, square root of 2. And the 60-degree triangle is going to be square root of 3, 2, and 1. As you notice, all hypotenuses are 2, okay? Those two flip, okay? And we'll go over those next time.